Hi there, Nikki Does here once again. I was asked a question about some unusual pumping applications by a friend last night, and it got me thinking that I should start to show some videos about the weird pumps that I have here in the lab. The first one I want to show, well, I can tell you about the application. The application was I need to pump a slurry comprised of, say, water. It didn't really matter what the liquid is. But in that slurry are some very fine beads, very fine beads, like 10 micron inch. Is it metric? I suppose it is metric. 10 micron, 0.01 millimeter diameter beads that are inside suspended in this liquid in a slurry. And it has to be pumped really accurately. So that rules out all sorts of impeller style pumps. Positive displacement is the key here, and the trouble with the slurry is it gets caught in the check valves of most pumps. So I got thinking about it, and didn't take long before I remembered one of my pumps. And this one, I have to give a little bit of a tribute first. I'm going to hold this up here. This is the Silog Accu pump. And Silog is sold to Parker Hannifin, I think. Still in business, or still selling the newer version of this, but this was designed by a very good friend of mine. The electronics, at least, were. The pump head itself was not. I'm not going to turn it on because it's really pretty boring. It just has two numbers, and you go up, down, and speed. This was designed in probably the mid 90s, I think. So it's pretty simple. Power inlet and a remote connector here, and how you're going to remote control it. I don't think it was serial controlled. I think it was like voltage 4 to 20 milliamps and 0 to 5 volts, and then it told you if it was actually working or not. Inside is a motor, and you were supposed to be able to remove these screws and take these 4 screws off and kind of remove the front and change the pump and keep the metal box and the electronics all together, because those were expensive and very difficult to manufacture in the 1990s. But I don't think that ever really worked out. I think if you wanted to change this, you really just bought another pump. I don't think that really came to fruition. That company was run by, I think his name was Charles Schick, Juliet and Charles Schick, and Juliet took over. I believe Charles died suddenly. I may have the first name wrong, but I believe he died suddenly. Juliet kept the company running for quite a while and ended up selling it to Parker Hannifin. So for all of those of you who out there who are starting businesses, this sort of thing was really a big deal then. You can do similar things now. I think they did relatively well. So that's all cool. I'm going to put that one down, and I'm going to switch over here to the other camera, and let's take a look. This is another of the same style pump head, only removed from the back. So I just wanted to show you how these FMI, or Fluid Metering Incorporated, pumps work. This one is a little older. Oh, there's the patent number. I was looking for that. This one's a little older, made in the USA, out on Long Island, New York. The company is still out there. I don't know, somewhere out there, but it's not. I'm sure that they're not made anymore in the USA. I mean, they just aren't. So these were patented. The number of the patent tells you approximately when in sequence it was, and the 500s and 400s thousands patents, or million rather, 4 and 5 million patents those are expired. Those are no longer in force. So if you wanted to make everything you see here and duplicate that, that is now public domain, and you would be able to do that with no restriction whatsoever. They're allowed to continue marking the patent numbers on there, that's which I think is great, but there's no force left in these patents. And in fact, I've bought, for a product I built some years ago, I've bought hundreds, if not thousands, of these pumps from FMI. So I had also explored Denier Precision Pump in Switzerland, and I think they're still around making these kind of pumps, but probably so are a lot of other people. Let's get into how they work, because that's the important part, right? I mean, obviously here we have a shaft with a flat on it, and you can spin that shaft. So, you know, big deal, it's a pump. But how does it actually function? There's another kind of interesting thing here. This is supposed to be mounted to a fixed base, and this is mounted to the black front panel of the Accu pump that I showed you just a moment ago. And right now this is supposed to have a locking thumb screw in here, so I think I'm just going to take this off if it comes off. I don't know if it does. Well, we'll leave it on. And it's supposed to stay stuck to this knurled wheel. So as I unscrew this knurled wheel, the black ring would stay with it. In fact, I'm going to steal the thumb screw from the AccuPump over here and just screw it in here just so this isn't flailing around quite so much. There we go. So now as I unscrew this, you'll see a line here somewhere. Is that it? Yeah, that's like the 0. Excuse me. And then we go around each time here and we uncover another line like you would do on a torque wrench or that sort of thing. And the question is, what's happening as I do that? So here I'm almost at 4. There's 3. Do not exceed 450. What do you think? Should we do it? Submit it in the comments. There's 4. 1, 2, 3, 4. There's 440. Here comes 450. I don't know. I'm a little nervous doing this. There's 450. I'm living right on the edge. We just blew up the world. All right, so let's go way past 450. And actually what we're going to do is slide this off. Zoom you out just a bit. This is just a ring, a threaded ring. It's got some grease in it. And all it's doing is pushing in on this ring, this kind of gold cadmium plated ring here. So when I tighten this up, it's pushing on this ring here, and there's a spring in there, so it's bringing that closer and farther. So if we look from the side, this is already loose, so that's going to be a little bit deceiving, but if we look from the side, it's bringing the axis of this pump in line with the axis of this rotation here. So if I were to screw that all the way down, the pump axis would be in line with the motor axis. So what, right? So you can see in here there's something going on. You can see the gold anodized aluminum piece rotating, and there's some black thing in there with a dot in there that's rotating around. There's only one of those. What is that all about? So the next thing we'll do is we'll take off this cap, just a cap, and this is the pump internals right here, and there's an O-ring in there which is kind of to keep things from bouncing around, and there's another thing in there that we're going to get out. There we go. I'm going to drop the O-ring. Again, that just keeps things from bouncing around. It's an O-ring, but it's not a seal. It just keeps things from shaking around in here. We have let's put this aside. We have a 2-part pump head here. There's a plunger portion that I can push in and out, and there's like a receiving cylinder portion. And the receiving cylinder portion has a port in there. I can see, if I pull that out, you can see it's uncovered. And it has another port on this side. And in fact, those two are concentric, so we could put a wire or something right through there. So here's this plunger. It's going to go in and out, and I can hear you now, and I'm probably looking at the comments, and I can hear all of you now saying, wait a minute, if it's a plunger, and this is a pump, and those are just holes, where are the valves? How do you possibly determine when you're going to draw liquid in through this one and aspirate it out this one, dispense it rather out this one? So we've got this pump like a syringe, and it should be valves. Well, the valves are built in. Trust me, they are. And there's a bit of a clue here. Let's see if we can make it happen here. So this is going in easily. I don't know if you'll hear this. There. Now, oh, right there. It's a little sticky and it's springy because it's trapping air in there. Right around a certain rotation. Well, how could that be with this piston-y plunger thing? Well, let's take it all the way out, and let's take a look at the magical bit here that's called a flat. So there is a flat here, and it's lined up with that post on the holder that holds this thing together. So there's my flat. I don't know what it is. If the cylinder is, say, yay deep, the flat is, I don't know, half of the depth of the cylinder, something like that. But it definitely coincides with those holes right there. So as this rotates around, that flat will uncover and cover these ports. So if I carefully put this, oh, by the way, there's a seal up here, but it's not really a seal. That Rulon weird paper stuff from the 1960s, 70s, it feels like an old material now. It's some sort of paper saturated with something, and I think it's got Teflon on it. There's a kind of a wiper in there. It's different than a seal. It's more of a wiper. When I put this in here, I have to be careful I don't fold it over. So I'm going to just take my time Normally I think you wouldn't take this out. So the other thing to note on here, and I think it's kind of interesting, if I can get this in here. The other thing to note is that this has I've wiped it off now. This used to have a number on it. I think it was 0.01. And that number would coincide with a number on this so that you would match these. So in the factory, they would have all these made. The tolerance between the plunger and the cylinder is what forms the seal. So the tolerance between those two is really, really important. So they wanted these as tight as possible. So I believe they would measure these probably with something like an air gauge, and then they would measure these plungers, bin them, and then associate the proper plunger with the proper cylinder. Pretty fascinating. I don't know, I think it's cool. So how does that ultimately work? Well, let's look back in here. That gold piece is, you can see the shaft, the silver part in the center with the flat on it and a set screw going into it. That is the other end of this shaft. There's a bearing here. And so that gold part rotates directly with the shaft, and it's on axis, meaning it just rotates directly around the central axis of the shaft. It also has in there that piece you see right down in the center there is a spherical bearing. Let's flip it around to the other side and look down our center hole here. So that's a spherical bearing, and that means it is restrained in one direction only, and that is the thing that's in the spherical bearing has to go around this way. Well, I guess it's two directions, two freedom axes of motion, because it can't go up and down either. But it can go in and out. It can slide in and out of that bearing, and it can orbit around that bearing. So it's hard to see in 2D, but it can go in any direction around there. So if this black part were perpendicular to the shaft, or if the center of this axis was concentric with the shaft, all that would happen is this pump would, whatever position it's in, it would just spin around like this, idly spinning around. It would uncover. You can just barely see through that hole. Let's get some zoomage in here. It would uncover like that. It would spin around, and then it would cover again. And on the other side, same situation. Uncover, spin around, and cover. Now, if we were to unscrew this some per that little gauge, so that's not on axis, now you can see that this spherical bearing is going to be farther from this surface here. The spherical bearing will be farther from this surface when it's up here at, let's call that 12 o'clock. And if we rotate down to 6 o'clock all the way down, it'll be closer down here. So because of that, this plunger at, say, 6 o'clock, let's call that here, will be in all the way. And when we spin around to 12 o'clock, it will be extracted some distance. So now we have a plunger action and we have a valve action. And plunger plus valves equals a pump. So that is how this works. If you are interested in more details, if you have questions, I don't know too much. I can't probably be an applications engineer for you, but if you have questions about how it works or need to see something else on it, please do put your queries in the comments below, and do not forget to hit the like button, and I would love it if you would subscribe, because that tells me that you're interested in the videos that I'm making. And as always, thank you so much for watching. Nicky Does.